Can I start? No?
So, welcome back from lunch. Thank you for coming back. And without any further ado, Marcelo Benites. Let's do an applause, please.
Okay, so thanks for coming, guys. And today we're going to talk about a testing strategy to automate the test of an Android application. I'm Marcelo. I work at Talkdesk. I lead the Android team. So why is it so hard to test an Android application? Well, at first, we don't have access to some of the constructors of the main components of an Android application, which makes it hard for us to change the dependencies for testing purposes, like the activity, the service, the application, the content provider, and so on. It's also hard to fake some events of the OS that are necessary for some applications, like the battery level, the location, the sensors. And on top of all that, the Android emulator is slow. So how do we solve those problems? How we make it possible to thoroughly test an Android application? Well, it starts with architecture, and with a clean one. And it starts by the domain. So having a set of classes that will have your business logic, and that will not be aware of implementation details like HTTP, SQLite, Bluetooth, and that won't have any external dependencies, including the Android SDK. If we do that at first, we'll have the possibility of running our unit tests on the JVM, the local JVM, without the burden of having to start up the emulator. Also, we can think about another layer we can call the data layer, that will work as an adapter. When the domain, or some of the classes that will satisfy the use cases, need to access an external data source, it will interact with this adapter layer. This layer has to be simple, and if it is too complex, it means that maybe there's too much logic in there that should be in the domain instead. This data layer also shouldn't have any external dependencies, including the Android SDK. Also, we can have a presentation layer, and this presentation will be composed by presenters, controllers, and view models. And when I say these concepts, these view architecture concepts, I'm not talking about specific Jetpack classes. I'm talking about the concept of a view model, a presenter, and a controller. So this layer as well doesn't have any external dependencies, including the Android SDK. Finally, we'll have the external dependencies, right? And they are outside of all of those classes. Those classes, the domain, the data, and the presentation layer are not aware of the existence of the Android SDK. RxJava, fragments, activities, room, retrofit, HTTP, Dagger, whatever. This is also a big advantage, because if you are able to actually produce an application that works like that, you could even take advantage of some cross-platform framework like Kotlin Native or Kotlin Multi-Platform, and share all the presentation, domain, and data classes between iOS and Android and the web. So the flow of control would work like that. You have a controller, and when I say controller, it can be a class, or it can be even the fragment or the activity itself that will have a handler for an event in the UI that will then trigger a use case. So this controller will have a reference to one of the classes in the domain that will satisfy the use case, and we'll call this class. This class will probably have to access some external data source in order to query data and to perform the logic. And this class will use an abstraction, a gateway, that is defined within the domain in order to call this external class. Then this adapter of the data layer will implement the gateway. Once the logic is calculated and we have an output, we can use another interface, a callback or an observable, whatever pattern you want. In this presentation, I'll be as simple as I can. I'll show you code, and it will work with callbacks. There won't be observables, but you could do it with observables as well. So the presenter will then implement the callback and adapt the data to the view. You see, this is an interesting slide because it's unusual when we think about model view presenter and model view model in the context of Android applications to have this separation between controller and presenter. Usually, the view model or the presenter is both the controller and the presenter. But this separation is interesting, and it's proven to be helpful sometimes. So let's talk about the testing strategy. And it will be composed by different layers of testing. And I think this is the aspect of this strategy that's interesting. When I hear people talking about automated testing, I see a lot of people talking about unit testing and end-to-end tests, but they forget about maybe some other layers that are also interesting. And also this strategy will be focused on the developer integrating the testing in his flow of development, using test-driven development and behavior-driven development. It's also important approach because it will assure that the code base is covered. And also we won't have some third-party person or entity making the QA. The team will be responsible for the QA and the automation. So the unit test will test these three layers in isolation, presentation, domain, and data. The integration test will be the integration between the data and the presentation and the external dependencies. The component test will test the integration of presentation, domain, and data by mocking the external dependencies. And these component tests are maybe the most important ones because they are more black box than the unit integration ones. And then they will provide the safety that you need to refactor the application. So since it's a black box that has an input and output, you can refactor the black box, run the component tests without changing them, and making sure that they pass and that your refactor is properly implemented. Finally, we have the end-to-end test that will test all the layers, including the external dependencies, including the server side or the database. It's really an end-to-end test. Those ones are more complicated to maintain, and they should focus on specific critical paths of the user in the application. So yeah, that probably you already saw something like that. So we have more unit tests, and then integration component end-to-end, and in the end, some exploratory tests. The reason why the pyramid is like that is because it's really tough to have a lot of end-to-end tests. It's really tough, it's complex to have component tests, complex to have integration tests, and it's simple to have unit tests. That's why we focus on the different scenarios and their edge cases more in the bottom of the pyramid. And as we go to the top, we will focus less in edge cases and more in specific behaviors or the critical paths of the user. So let's show some code. So I came up with this idea of a conference application since we are in a conference. And I will describe the story and the scenario like I would do at work. That's how we specify our stories and our scenarios at top desk. So as a user, I want to see the conference details. Given a conference register with name Droidcon, when I open conference application, then I see Droidcon on the screen. It's super simple scenario. And but although, okay, this is a simple example, but this is probably the approach that will make the team develop faster. One of the main problems that we find when we have a software development is the understanding of the problem, irrespective of the implementation by the development team. So we use this language not to automate, to use some tool to create tests, automated tests. We use that as a language to communicate between different stakeholders, like the designer and the product manager and the development team in a meeting on the fly. So we have the input, the idea of what should be done, provided by the product side and probably the designer with some wireframe. And we are going to translate that in a story and a set of scenarios with the team. And then we have that as a contract between the business and the development team. And there's no, it's simple, it's clear, and then the developer can focus on how to implement the scenario. We also use test-driven development because of the reasons I mentioned before. So yeah, we will begin with that, with some unit tests, and we'll begin by one of those layers. And I also favor the domain. The domain is the most important layer of this architecture. It's the layer that has more value for the business, and it's the layer we should focus first. Also, one thing that probably most of you guys will think it's unusual in this presentation is how the state is managed. The state will be managed by the domain classes. So I know that we have some nice Jetpack, view model things to do that, but by having the state in the domain and having the domain associated with the application lifecycle and having the domain agnostic to any changes of the view, so it doesn't matter if you have configuration changes, if the view disappears, the domain doesn't care about it. It will continue to execute the use case. This is really, really powerful in Android. So in order to implement that, this is a simple state object, and we use that at Top Desk. And with these 4 states in this state machine, we'll have all the scenarios that we need covered. So we have like loading, then we are loaded, or we have an error. And if we are loaded, we have a value corresponding to the state. There's also a state machine implementation that I'm not going to show you, but I think you are going to understand by the next steps what it does. Also the threading. So the threading also is part of the domain. The domain will control the threading. And to do that, and in order not to leak details, implementation details in the domain, we have to create an abstraction. This is also another example. You can have something different. But this is a dispatcher that the domain will have an access to in order to dispatch work. And the domain can have a callback of a success or an error with a throwable. There's also the option to dispatch without caring about the error. It will be especially interesting in case you want to dispatch in the main thread. We're going to have implementations that dispatch in the main thread, and another implementation that will have will dispatch the work to a background thread. You can use a Rex in order to implement that. Actually, that's what we do at Top Desk. We have an Rex dispatcher, or Java dispatcher, and we use that to dispatch the work, both to the main thread, or one implementation to dispatch the work to the main thread, and another one to dispatch to a background thread. So when we start the domain, usually it will come up as we are creating the test, but to make the presentation better, we are going to do it in a different order, like we do some upfront here. So we'll think about the data context. We know that the conference information will come from an external service. We already know that. At first, we'll try to forget about the details of where this data comes from. We're going to focus, but we know that we have a model, a data class, that's a conference that has an ID and a name. and that we have an interface to query this information. There's one important decision that was made in this interface. The decision is it's going to be synchronous. And it will make, since the domain is responsible to dispatch the work and to control which thread, in which context the work is being done, it's easier to have our data source whenever it's possible synchronous. So I wouldn't favor returning an observable or a callback from this layer. I'll just let the domain control the threading and call synchronously the data layer through this gateway. So we're going to these 3 steps of the test. That's we arrange the test, we prepare the state of the system, we act on the system, and then we verify that if the system behaved properly by asserting. So let's arrange. So this would be our first test. It would be how I would approach this problem. This notation of Kotlin is quite interesting to describe the test. We can have a normal language. And given a register conference, when start is called in this state machine that represents the business logic, then it should emit the loaded state with the conference. So in order to prepare the state, I will create a conference. I'll create this state machine, the conference state machine, and I'll inject on it 2 fakes. It could be mocks, but from my experience using fakes, it's easier to maintain. So it's easier to change them, and if you have mocks, you have a burden in changing the behavior of the classes that you are mocking. So in general, I will favor fakes and use mocks only to verify behavior. So we inject this fake dispatcher that will be synchronous, so we don't have problems with the task being asynchronous. It will run sequentially. And then we'll have the fake conference gateway that will just return the conference that I just instantiated. So here we have a mock. I'm using mock with the K. It's really nice. I think it's better than Mockito for Kotlin. But whatever you feel better, whatever tool you feel better. I mock the listener, and this method that comes from the state machine class that I told you about, that conference state machine inherits from. But it basically does is like you change the state and it notifies whatever changed state listener is registered. So I registered this mock. I'm ready to act. I will start the state machine. In this case, the start will be responsible for loading, because typically, since this is the first screen of the application, in the onCreate method of the application, this method, I will start all the state machines that I have. And in this case, this one will right away load the conference. So I can assert, and I assert that first the loading state came up, and afterwards it was loaded with the conference that I prepared. So the test will fail, and I'll have to make it pass. This is like a small joke because we would be creating this conference state machine as we are creating the test. But I want to show you, and this will be the only implementation I'm going to show you guys. The rest is going to be only tests. But this is how the conference state machine would look like. It will just load the conference by dispatching the work, moving to loaded after the conference gateway returns. And in case there is an error, it will move to error by passing the throwable. So since we already have the domain implemented, we can move to presentation. I will use MVP here, but really I don't care. I think the architecture of the view layer, you can choose whatever architecture is better for the view you are implementing. But for the sake of simplicity, I'll use MVP in this presentation. So first of all, doing some upfront, we have to define the view contract. Probably you are already aware of that. Probably you do that already. So this is a contract. Simple. The importance here, the important thing here is that this contract is quite simple. So the GraphQL interface that implements this contract is super simple and dumb. So we're ready to arrange, since we have our view contract. We'll mock it. So here our scenario is given a loaded conference. When the state is updated, then show conference name. This is the nice thing about that. I'm just focusing on the happy path since the domain. But we could already in the domain layer think about error states, and test them, what should happen if an error occurs, When I'm loading the conference, it should be, an error should appear, should be a callback would send an error. So here as well, I'm thinking about the happy path, but probably you would already think about how your view would behave in case an error occurred. So we mock the view, we inject the mocked view in the presenter, and also we inject the dispatcher. Why? In the real world, this dispatcher will be the main thread dispatcher. The presenter, before it touches the view, it knows that it needs to dispatch the work to the main dispatcher, to the main thread dispatcher. And this approach is also interesting because sometimes before you want to actually post the results in the UI, you still want to be in a background thread in the presenter. Maybe you want to identify the receive a list, but probably already have a list in the UI, and you want to have the difference between the two lists and only update the difference. You could do that in the background thread, and then when you're done, you dispatch to the main thread and touch the view with just the subset of items that changed. This is an example where it would be helpful to still be in a background thread in the presenter. So we prepare our presenter. It's synchronous. It has the new view mock. We can act. So this invokes just because the presenter implements the callback, invokes like the function of the default method that a function has in Kotlin, right? So this is a function, the presenter implements the function, the presenter will be passed to the domain, right? When the domain changes, it calls the presenter. So the presenter, let's simulate that the presenter received the loaded state and received the conference. And then we can assert that our view has hidden the error, has hidden the loading, and has shown the conference name properly. If we do that well, we are safe, we feel safe of not testing the graphical user interface. We don't need to. If we have a clear presenter, a good architecture in the view layer, we have view models when we need it, we have presenters when we need it, we have controllers when we need it. We don't need to unit test the actual graphical user interface, like the fragment or the activity or the views. So the data. The data could have some unit tests, but in that case, I see no value. I go straight to an integration test. So the integration test is not, this definition is not what maybe you're used to. I'm not talking about the integration between the app and external service like an HTTP server. I'm talking about the domain, the data layer, and the domain integration with an external dependency. We'll see now how it looks. So in order to arrange, we are going to, since I decided that I will use OKHTTP in order to implement the data source, I will use another tool that's also available that's called Mock Web Server that allows me to have a local server in my test in order to do the integration test. So here's the arrange step. When a conference is requested, then we call conference endpoint with get method. So what I'm verifying here is that my code fulfills the contract that the server established, right? I'm not actually calling the server because I'm using a mock server, but I'm verifying that my code respects this contract. This is a common, like we start a server, I will instantiate my OKHTTP conference gateway, inject my mock server URL and a normal OKHTTP client. I will include a response of success 200 and with the JSON of the conference. I'm ready to act, get the conference, and I'm ready to assert that the proper conference was deserialized from the JSON and that it was returned by the gateway. I assert that the correct method was used and that the correct path, the correct endpoint was called. I assert that the contract is fulfilled. Okay, we already have tested in isolation the layers and also had an integration test proving that we have a proper implementation using OKHTTP that fulfills the contract of the domain. So now we can move to a component test. The one that I told you guys, it's maybe the most important one, the black box one. Here I will use a fake graphical user interface. But it's up to you guys to decide if you want to run that in a real emulator and use the real Android SDK for the graphic user interface. Probably you had a talk about Nitrogen, the project, so it is possible now. It's been a couple of years that Google is pushing, I don't know what's the state of that right now, pushing the integration of Hobo Electric and Jetpack and Espresso. So we'll have the ability to write a test using Espresso notation and decide if you want to run using Hobo Electric in the local JVM, or if you want to run in an emulator or device using an emulator or device, the real Android SDK. I'm favoring using Hobo Electric here because it's way faster, and I want my tests to run fast. So we'll have to have dependency injection here. I do that sometimes just to prove that you don't need any framework to do dependency injection. Dependency injection is not Dagger. Dagger is a dependency injector, but you can do dependency injection by yourself, and that's what I'm going to do. So I'm going to create a couple of interfaces in order to do that. A dependency manager that will provide the conference state machine and the main dispatcher, and a view container that will later be implemented by an activity that will then handle the dependency manager to the views, to the fragment probably that we needed to perform the logic. So I'll create a test activity. This test activity will belong to the test folder, and it will implement the view container, and it will expose the dependency manager. I will open a backdoor, let's call it that, in this test activity, so I can replace the dependency manager. Probably it would be the same thing you would do with your Dagger components. So if you're using Dagger, probably here you would have a backdoor to replace your application Dagger component. And also I'll create this easy to show fragment. So it's easy to show the fragment I want in this activity. So we use this, this is the test. It's placed in the test folder. It will run in the local JVM. And the reason why it will run in the local JVM is because the Android JUnit 4 will verify where the tests are, and will decide if it will go for the Roboelectric runner or the normal instrumentation runner. So the Android JUnit 4 will verify that, okay, this is our normal test, so they are not in the Android test folder. So we use Roboelectric runner to run them. And this is normal Espresso notation and normal instrumentation test notation. I'll create this rule that will use the test activity. And I'm ready to arrange my test. I will use the same principles that I use in the data layer integration test. I decide to go for the mock web server as well. I enqueue the response. I create my real state machine. I inject my OKHTTP conference gateway, but it is pointing to the mock web server. And I also inject a fake dispatcher because I want it to be synchronous. I start the state machine, and I replace the test dependency manager with a fake dependency manager that will provide this state machine that I just created. And that will provide fake dispatcher as the main dispatcher. I'm ready to act. That's basically showing my fragment, my conference fragment. And I can assert using the normal Espresso notation that what happens is that Droidcon is on the screen. Right? And I shut down the server. I hope you understand that this is an example that's quite simple, but as your application grows, the state machines will probably depend on other state machines. And this test will have more and more value because you'll have more and more classes integrated. And it will also be better to test different behaviors and verify that application works properly. The important point is that we are just faking the minimum amount of code that we can fake, right? We are just faking the part that we cannot have running, otherwise we would be performing I/O operations in this test. We would be calling our server. Our test would be way slower and also flaky. Because if you have some intermittent connection problem or something like that, they would fail, they would provide false negatives, and they would probably, the developers would lose confidence in this kind of test. If this is fast and this is reliable, it can run in the CI every time a PR is open, for example, a pull request. Okay, finally the end-to-end tests. The end-to-end tests are the worst ones because the arrange step is really, really complicated. It's really complicated and it's really flaky. It's flaky because it will run in an emulator or on a device. And if you already did that, you notice that as much as you try to use Espresso properly, there will be some times where it won't work. It will be flaky. It will be flaky when you are probably messing with a search view or a dialog is appearing and you try to hide it, stuff like that. So it will be quite complicated to have reliable tests if you're using Espresso, even if you make them synchronous. And the arrange step is complicated because of the server side, right? If you work in a big company like I do, when you say server side, we are talking about a lot of microservices, a lot of different layers. And since this test will actually interact with the real system, sometimes you'll have to call APIs to prepare a specific environment. I would probably run this kind of test in a staging environment. And in the test, I would prepare the state of this environment for a specific test account and then run the test. And even when I do that, they can fail because they are interacting with the test is performing an I/O operation. So I will skip this arrange step, and I'll just act like the state was already in a known state. And it's quite simple, right? I'll just, this will be in the Android test folder. I will launch my activity. Since my main activity in this case is already displaying the conference fragment, I can assert, and in order to assert I have to, this is another flakiness, this probably will make the test even more flaky because there's a thread slip. You could try different approaches, but in the end, you could have the same problems. You could you try and do a loop and wait for some state in the UI instead of sleeping, but in the end, the results are the same. So we wait a little bit and then we verify normally that the text is there. This is not a good example of an end-to-end test. An end-to-end test would probably simulate a path of the user in the application. So the user will start logging in probably, and then will do something that usually the users do, and this is probably one of the most important things they do in the app. For example, we have a talk desk. Our app is to make and receive calls, mainly. So we will have to have a way of having an end-to-end test where we make a call, and we verify that the call works. We log in, we make a call, we verify it works, we hang up, we log out. This is one of the critical paths of the user. Probably we'll have few critical paths, because these tests are really hard to maintain. They are the ones that verify that the main and most important features are not broken. The other parts, the edge cases, the other more complicated or more unusual behaviors are verified by the other tests. The other tests that run fast and that are reliable. So, by having all these kind of tests, we have more confidence in changing the application, and we also move fast. We move faster. I heard a lot from people that it's really hard to convince management, it's really hard to convince my boss that I have to have this kind of automation, that I'll have to use TDD. But I think if we first try to do it well, to know how to do it, invest time, maybe personal time, to really master the way of doing it, understanding how to do it in our technology, we can prove to these people that we will move faster if we do that. If we have a team that has it in its blood, do TDD, We have good specification of BDD, and we move faster. And we move faster and faster as the code base grows. Faster in a way that we still deliver with the same speed. Like the first story, when you have greenfield and you do it and it works, you keep doing that as the code base grows. And I think this is the big advantage of doing that, and of having that together with the development flow. It's not something done afterwards. It's done during the development. So just to give you some data, what we have right now at Talkdesk, we have just 1 year. The application has 1 year. It was never developed by many developers, for like 2 or 3. So we have 500 unit tests and integration tests. I don't know exactly how many unit and integration, but we have 500. Then we have 50 component tests. And we have around 4 end-to-end tests. You see, only 4, because it's the main, the critical paths of the user in the application. This is a reference. These ideas they all come from mainly those articles. Robert Martin, the Martin following test double concept, and mainly these testing strategies in a microservices architecture from Martin Fowler. Also, there's this managing state with RxJava. That's a really complicated talk from Rick Wharton, that he tries to basically build the state machine that I described, but using Rx only. I don't recommend doing that, so it's too complicated, but I think the concepts are there. The concepts of having the state, the domain as a state machine, and then publishing the UI. And I've written a blog post in Medium. It's been a while. It's a little bit different than what I presented because we improved since then, but also it's available in the Medium of Talkdesk. Also, there's in my GitHub you can find all this code, a little bit different, more complex. You can find it there as a reference. I have other repositories where I implement kind of the same idea. I hope that at Talkdesk we can, in the future, have a framework from this state machine and state ideas, and we can open source it to the community. Oh, and that's it, guys.
Questions?
Hello. Great talk, by the way. Thank you. Question around the end-to-end test. Is that something that you have running on your continuous integration per pull request, or is it like a sanity every night kind of a deal?
It's not running in every pull request because it would be too slow and flaky. Yeah. This is something I didn't say. Like this kind of tests, they have to be double checked. They have to be, because the arrange step is so complicated, and sometimes it fails because someone in one of the microservices, other parts of the company, changed some configuration that impacted the test. So some other person, if you have a QA person, maybe this person can run this test from time to time before you deliver or you deploy. But because this person will have to double check the results.
Hey, nice presentation. I would like to know about end-to-end tests as well. And I saw that you put that thread. I know the thread zip was only for tests or for presentation, but
we use the thread zip.
Okay, but you indeed use.
Yes.
Because I was thinking about have you ever considered to use like either resource, or do you have any opinion against it or a favor?
Because the problem with idle resource in this case is because you have to change the code on the test, right? You have somehow to inject some class that would notify you that it's over, right? So I don't want to change the code. I want to have the real code that goes to production being instrumented. Yeah, that's the reason. Otherwise, I could inject the fake dispatcher, right? Yeah. So it's just I want the real. And I know you asked a lot about the end-to-end tests, but they are the least important ones. I don't care about them. You know, the important ones are the other ones that will allow us to move fast.
Sorry again. I wanted to end. You say that you have few of them and you don't run them because they're flaky. But if the test fails because someone changed something on a microservice, wouldn't the app fail as well?
Yes, that's why we have them.
Okay.
That's the only reason we have them, right? Because we cannot be sure that the app works in isolation. We have to make sure it works with the rest of the system. And but if you put that on the CI, it will be slow and flaky, and your CI would fail. And I don't want to slow down development because of that. You know, this is really tricky to decide, but you have to run them from time to time, probably after every deploy. This is strange because this is really hard because this is not really continuous deployment, right? If you have a step that has to be verified by a human being, it's not real continuous deployment. You know, that's the way it is. I mean, I cannot make sure it will work. Maybe it's a third-party service that you're using that's down, but it's important for you to know, right? So you have to do this kind of tests. But let's keep it to a minimum because it's a lot of effort to maintain, right? Maybe it would be the only time where I would consider having a separated team. Like the QA team would only work in automating these end-to-end tests and running them from time to time and maintaining them because it's really hard to maintain.
So that's it. Thank you, Marcelo. That's a good question. We'll have a small break before the next session.